All right, so today we're going to take a look at two equations and see where they intersect, and we're going to get a better understanding of what this intersection means and why it's important in mathematics. So if we take a look here, let me see if I can get my pull up here. Yeah, here we go. You can hear my son's very excited about it. We have two equations here. And the question is, what does it mean, this point where the two equations intersect each other? So the first thing we have to do is we have to give context to these equations, right? It'd be a shame if it were just c equals 80 plus 4t. That doesn't do anything in the real world. But what I can tell you is sometimes you want to buy merchandise for your company or for your class trip or whatever it is you might care about. And you might look at two vendors. So we'll call this one vendor A, and we'll call this one beneath vendor B. Now, the second thing you always have to do with math is you have to stop living in this world where there are just a bunch of letters and numbers, and you have to ask yourself what they represent. So in this case, C represents the total cost, okay? And that's true for either one of these equations. C is equal to cost. The other variable we have here is T, okay? And in this case, T will be the number of t-shirts. And so when I initially look at this equation, the first one from vendor A that says C equals 80 plus 4t, well, 80 represents a static number. It's a total amount that you have to pay just for buying from that vendor. So what the first equation is saying is you have to pay $80 just to talk to this vendor, just to get out the door, and then $4 extra for every shirt that you purchase from them. The other vendor, vendor B, has a different deal. They make you pay less up front, so $20 as opposed to $80, but $7 for every shirt. And so logically, the thing that hopefully you're thinking is, I'm trying to save money in the long run. It's going to matter how many shirts I buy. If I buy very few shirts, vendor B might make more sense because you have to pay fewer dollars up front to vendor B. But each shirt is worth more money at vendor B's establishment. So vendor A suddenly gets way more attractive after a certain number of shirts. Now, we've done all of that logical work before we've ever even fully looked at the intersection between these two lines, okay? So once I take a look at the two lines, we can see that the blue line right here represents vendor B and the red line represents vendor A. The intersection would be the point at which vendor B starts costing more money than vendor A. And you can see that vendor B, that line, becomes higher on the y-axis than vendor A's red line after it looks like 160 shirts, okay? Or a cost of $160, I should say, for Y, and therefore 20 shirts for X, right? The x-axis in this case represents the number of t-shirts. The y-axis represents the amount of money spent. So if you're spending more than $160, you suddenly want to start spending money with vendor A as opposed to vendor B because vendor A is going to cost less money overall. And that's the representation there. Both those numbers are important, 20 and 160. And this is why we have two coordinates when we're working with what's called a Cartesian coordinate plane, which is just a fancy way of saying, hey, some guy a long time ago recognized that there are two variables playing here. 20 is the number of t-shirts, and that's our x-axis. And 160 is the amount of dollars spent. That's our y-axis. So what you can then logically say is, hey, if we're buying 20 shirts or fewer, we should probably go with vendor B. It's going to cost less money. But once we get to 20, it doesn't matter. And above 20, so 21 shirts and above, you probably want to go with vendor A. It's going to cost less money because the cost per shirt cancels out the initial $80 you have to pay to get out the door. So I want you to take a moment and I want you to take a look at some of the problems that we're working with intersecting lines. And I want you to map out what does the first equation mean in context? What does the second equation mean in context? And what does the intersection represent as an idea?